You all are able to see my screen?
Yes, sir.
Okay. So we'll make a beginning. Last class we saw what data structures are. So data structures are basically the way you organize data in the memory, and we saw what all operations we can perform on the data stored. We always organize data to simplify searching, sorting, locating, inserting and modifying the data. Now we looked at the example of a array list. So in that we did reading the elements at a particular location. So that could be done in O1 time. It means the time taken to read an element at any position is independent of the location of the element in the list. So this is a fixed time taking operation. However, if you want to search an element, this would take ON time if you use linear search. If you are using binary search, it would take log n time. Now, the way to illustrate that is, suppose you have n elements equal to 64. Then if you use linear search, it would take 64 operations in the worst case and only 6 operations if you use binary search. So it depends how you do the search. Similarly, the size, if it increases to 128, you see quickly the time taken to search will also increase tremendously. However, the delete operation would take ON time, depends on where the element is. So on an average, it would take n operations, because every time you want to insert, you have to make room for the new element and insert that object. Similarly, when you want to delete something, after deletion, the elements have to be compressed so that they all remain consecutively allocated. So these are some of the performance indicators of your regular array list. Now, one issue with this particular data structure is that it is static. That is, it is of fixed size. Once the maximum size is reached, you are not able to store the data elements anymore. So this static nature of data structure is quite undesirable in today's application scenario. So we want a data structure which would grow automatically if whenever the limit is hit. So what is more desirable is that your array list should be able to grow dynamically. So for that, we have to design a new data structure, we can call it as vector list, where initially the capacity of the array list or the vector list will be 2. The vector list size will be initially 2 here, and gradually can grow as more and more elements are added. And the size of the vector list is initially 0. There are no elements. As you can see here, assume that this is your vector list. You can name it as my vector. Initially size is 0. There are no elements, and capacity is 2. It means it can accommodate only 2 elements initially to start with. Okay. Now if I insert the elements here, for example, if I put number 9 here, now the size becomes 1 and capacity remains 2. If I insert one more, then size and capacity will become equal. Size will become 2, capacity is 2. Now if I want to insert one more, this array must grow automatically. It means it should enlarge itself, maybe let us say double the size. So the capacity should become double. So what I can do is allocate 2 more memory locations here and make the capacity 4. So that if a new element comes, I can insert that number here. Okay. And again, if you move on, if you enter one more, again capacity is full. This time I can increase the size to 8. So the capacity can grow to 8 size. So this is one logic that is employed generally. Why double the size? There is no answer for it. You can make 1.5 time also. It is left to you. But 2 is more accepted multiplication factor. Okay. So let's see how I can build a vector list which is dynamically growing. Let me take you through. Okay, now, how do I implement a new data structure which is dynamic in nature? So for that, we have to define a class. So class vector list, and here I am not going to use an array A of max size. It's going to be a pointer now. All of you are aware that array name is a pointer. Only thing that was static pointer, I am taking a dynamic pointer here. So int star A is a pointer now. Now there are 2 data members, capacity and size. In the constructor, I have to initialize this. The capacity to 2 and initial size of the vector is 0. Okay. And this array has to be allocated space of 2. So what I would do is A equal to int star malloc size of int into capacity. So what will happen now? Integer is of size 2 bytes, so 4 bytes will be allocated. It means it can hold two 16-bit data objects, okay, initially to start off with. Size is 0, capacity is 2. So this is where the vector gets initialized. Now we need to see how I can implement this add element. Now while
Is that size and capacity is the default numbers what you have given, or is it modifiable based on the requirement?
no, this is how we intend to implement vector list. You can say capacity 4 and size has to be 0 always, right?
Yeah, initially it is 0.
Initially size has to be 0. Capacity can be 4 initially, 10 initially. That is left to you.
Okay, based on when it is growing, it takes
Yeah, as
double the
it
size.
grows, it will increase. No, there is no point allocating 10 bytes initially, because you may use only 2 of them. So you have to conserve memory also and see that it grows to accommodate more elements. So that is why this is like this. Now, while adding element means I have to add the element at the end of the list. I will use size only as index into the array and put that place. Now before I do that, I have to check if your size is it less than capacity minus 1, because there should be at least one space available to add. No, suppose capacity is equal to your size equal to capacity, then you cannot add. So there should be at least one place for you to insert that element. So if size less than capacity minus 1, then I can a of size equal to x. The element x which has come has to be inserted here, isn't it? And the size must be incremented by 1. I can do that right here. Now this is when there is enough space you are able to do this, but in the else part what might have happened is size has become equal to capacity, isn't it? So in that case, what will you do? You have to double the size of the array. You have to reallocate. So for that, you have to take one more temporary pointer, and you can use instead of malloc, you have to use realloc, where you specify the initial array and the new size that you want to allocate. So here it should be size of int into 2 times the capacity, whatever is the current capacity, into 2. Okay, and then this pointer has to be aligned to a. It should be copied to a, because a only should be used to point to the array. Now here I am going to insert the element. So a of size plus plus equal to x. Now there are two cases here. If you have enough space, you directly insert and increase the size by 1. If you have hit the capacity, then you have to allocate double the size and then insert the element into the array and increment the size.
Sir, when it is said vectors will dynamically increase the memory location to double the
Yeah,
size,
this
right? But why
reallocation,
are we doing it?
reallocation is doing that.
But we are calling the realloc, right? Should we call it
you have
by
to
ourselves?
call, you have to implement this.
Okay.
Okay, so this, if you are saying vector list is a dynamic data structure, then you have to take care of this. Now one problem we have made is we have not changed the value of capacity. So what you should do is capacity equal to capacity into 2. Okay, because capacity should also be altered, and then just pass capacity here instead of doing all this. Isn't it? Now initial capacity was 2, now it becomes 4. Next time when you hit the 4 boundary, then 4 into 2, 8 it becomes. Isn't it? So array size is dynamically growing. Get this? Okay. Now we'll see the operation of this. I have insert after, we shall see later. Display I'm doing for I equal to 0, I less than size, I plus plus, and then all this. Okay, so just the regular way you display the array. And if you want to display what is the capacity and size, you have to getters here, get capacity and get size. Okay, so let's see the operation of this when I create a vector list. So I say vector list, my list. So if I just create this, automatically the size becomes 0 and capacity will be 2. Now to this list, if I add an element, now size is 1, capacity is 2. Okay, that you can display and see out. Size equal to my list dot get size and capacity my list dot get capacity. Okay, now we will see first we shall display all the elements, my list dot display. So only one element is there now. So one element will be displayed and you will see the size has become 1 and capacity will remain 2. So run the program. I think it takes some time. Yeah. So as you can see, we have stored 7, size is 1, capacity is 2. Right? You can also insert one more, my list dot add element, let's say 9. We shall put one handle here. So now if I display, there will be 2 elements, size will also become 2 and capacity will be 2 there. So 7 and 9, size is 2, capacity has doubled. Okay. So as you can see, moment you hit the capacity, the size will become double. So that next time when you insert, there will not be any problem. Isn't it? So if I again insert one more, it will safely take that number. This time size will be 3 and capacity will remain 4. Okay, so there are 3 elements, size is 3, capacity is 4. So as you can see, the list is dynamically growing.
Now fourth element will increase the size, does it?
Yeah, now just see what happens if I add one more. Yeah, because now all 4 are occupied, size became equal to capacity, the capacity got doubled to 8. Right? So never there will be a case where your array will become full unless you hit the maximum memory available in the system. So this is a dynamic array. So we solved the problem of the static array by employing a logic where I enlarge the array dynamically using realloc function. Okay. If you remember, we discussed vectors in standard template library. That standard template library vector is doing exactly this, isn't it? So there also we had size and capacity. So how it is internally implemented is what is seen here. Only thing, that vector was a generic class. However, we can also convert this into generic class by using template and converting this int star a to t star a and all that. Okay, so that can be worked out. So far so good. You understood?
Yes, sir.
Okay. Yeah. Now insert after, if you want to do. See, when it is data structure, you may have varied requirement. One of the requirement is given in an element X. This you have to search whether it exists. If it exists, after this element, you should insert the second element Y. Okay. So what you should do is you should set up a loop for int I equal to 0, I less than size, I plus plus. You first check if a of I equal to x, it means the element is found, isn't it? Then you just break the loop and you want to insert y after x. It means what? All elements after x should be shifted to the right, isn't it?
Sorry, sir, can you repeat? I mean,
See, now we have these elements.
okay.
And you want to insert after 5. Your
Okay.
x is 5. You found that x is at position 1. This is index 0, this is 1.
Yeah.
After 5, I want to insert, let us say, y equal to 9.
Okay.
So what should happen? This 4
what
should
is-
shift here, 3 should shift here, and 2 should shift here, and 9 should come here. And all others should remain like this, 6, comma 5.
Okay.
Okay. So this is insert after.
Okay.
Now this loop will only find out where is element x, and after x, that is I plus 1, you should insert the element. But at I plus 1 you have 4. So I need to shift all these 4, 3, 2 towards the end. Okay, so for that I have to again set up a loop where for I must shift from the end. 2 should be shifted first, then 3 should be shifted, then 4 should be shifted, right? So I'll take one more variable j equal to size, isn't it? J greater than I, j minus minus, and here I should copy a of j equal to a of j minus 1 equal to a of j, right? See, j is ahead. It is at index 2. It is initially at 2. Now 2 has to be copied in place of what I did. Yeah, sorry. This should be j plus 1 equal to j. So this 2 should be shifted at j plus 1. 3 should be shifted at j. Likewise, until this j is greater than I. It means until you have reached after 5. So when you come out of this loop, here you should actually insert the element a of I equal to y. Okay. So the second for loop will shift the elements, and this last statement will put the element at appropriate position. Yeah. Now one problem is this I is local to this. I should have declared this I outside here. So if you declare int I inside the loop, it will have local scope. It will not be visible after that. So that is why int I should be declared outside the loop and used. Whereas j is required only here. So j can be declared like this. Yeah. Now one problem here is, suppose size is almost at the end of the capacity. So then there will be a problem here. Okay, so that logic has to be built in. Now what I do is that logic is slightly complicated. I will just copy that insert after, which I have here. Because while inserting also you may hit the maximum capacity. So for that again reallocation has to be done. So the code becomes so complex, right? So this part you know why I'm doing. I'm searching for that element. After that, if index is less than size, I will shift the elements and store y and increment the size. But suppose this index, that is variable I which I used earlier, if it has hit the capacity, then again capacity has to be doubled, reallocation has to be done, then again shifting has to be done, then element has to be copied. Otherwise you have to say element does not exist in the list. Okay, so much program logic you have to implement to get the insertion done correctly. Okay, so let's see whether this works for us. For example, here if I say insert after, let us say I want to insert after 9, I want to insert 3 or 4. So 7, 9, 4, 11, 12 should come in the output. And if you want to display the list after insertion and also display the capacity and all, should do this. I think so. This should be insert after. Insert after. Why is it not taking? Identify.
Sir, D is missing. Insert.
Okay. T is missing.
Insert T.
Yeah.
T is missing.
Okay, good. Still no. Or in my definition, I made some mistake here. Should be object name my list dot. Yes. Okay. Now let's see whether this insertion happens after the element 9. Yeah. So 7, 9, 4 is inserted and 11, 12 are shifted. Okay, so there was enough capacity, there was no need to double the capacity, it went fine. So like this you can just try until size becomes equal to capacity. What happens after insert after also should work correctly. Okay, so you should be able to build data structures which are flexible. They should be able to do their job well, but at the same time they should be flexible like this. You cannot have an array list which is static and every time you hit the array capacity, you will have a handicap that you are not able to insert more elements. Okay, so this is a more desirable implementation of a array data structure where the array size grows dynamically as and when the size hits the capacity. You followed this?
Yes, sir.
Okay.
Sir, one question. Can we add 2 elements in one go, or there would be different logic?
Yeah, you can insert 2 elements. Then you should have insert after int x, int y, int z.
Okay, that will
And
become a
then
vector.
shifting has to be done with 2 locations.
Okay.
And then here it should be a of index plus 1 y and then a of index plus 2 equal to z.
Okay.
And
So every
size should be size plus 2.
plus 2. Yeah.
Okay, so all that logic will change.
Change that. Okay. Okay. Got it. Yeah.
Yeah. Okay. So
But to add element also it will change, sir. Int x, int y.
this one, yeah, here if you want to add 2 elements, then again it should be a of size. Then you should check whether capacity minus 2 is there. Size less than capacity minus 2. At least 2 locations should be free, no?
Correct.
Then you have to add that. And here, when you double the capacity, you should be able to add. And again, size has to be incremented by 2 here.
Correct.
Okay. Or you say a of size plus plus equal to y, and here also a of size plus plus equal to y.
Right.
If you are inserting 2 elements, right?
Oh.
Okay. So maybe I'll give that as an exercise and you can try that out.
Yeah.
Okay. So far so good. You understood what array data structure is. Okay. So in this memory allocation is contiguous. That is what you should remember. And that is why it is linear data structure. Okay. Now next in the list of data structure is stack. Now, all the while in our C programming and even C++, we are talking about variables are stored on stack. So stack is an arrangement of data elements in memory in the form of a stack. So you know what is a stack. If you put the books on top of each other, it becomes a stack. So you have to follow certain rules. If you, as you put the books on top of each other, you cannot pull out the books below. You have to pull out the books only from the top, and you can add the books to the stack only from the top. So that arrangement will be there. So if I define a stack, initially it is empty. So to indicate an empty stack, I say top equal to -1. It means there are no elements in the stack. And the maximum size of the stack is max -1. Now here again, initially we'll consider a static stack where the size of the stack is fixed. Okay. Subsequently, we shall see how to make it dynamic. The same way where we did the array list dynamic, stack can also be done like that. Every time you hit the maximum size, you double the size of the array. Ultimately, stack also is an array. We shall see array implementation, also linked list implementation. Both implementations are possible. Now, when you insert elements into the stack, your pointer grows or it increases. For example, in the stack, if I enter 371 or push the element, this operation of putting the element in the stack is called as push operation. So the top will point to index 2. This is index 0, index 1, 2. And in fact, I should have written just a minute. So here the top should point here. Okay. And if I insert one more, this top should get incremented and point here. So as you can see, the index top is growing vertically and more and more elements are added. Right. So this is the push operation. If I say push 5 into the stack, the elements get stored like that. Similarly, we can remove the element using pop. So pop will not take any argument, it will return the value at the top of the stack. So if I do pop, I'll get 5 and the pointer top gets decremented by 1. So if you see, this pointer will point to element 1 once you delete 5. So the stack can grow vertically and grow downwards when you do pop. Right. So like that you can have a method display also, which will display all the elements from top to bottom. So if I say call display, I should get output as 173 like this with top pointer pointing here. Similarly, you can implement a function called as peek. So peek will tell you what is the top element. So this will return always the top element. In this case it is 1. Right. So we can define stack data structure wherein we do push and pop from the only one end. That is why it is called as LIFO stack. Last in, first out. The one which goes last into the stack will the one which will come out first. Okay, so if you see, this one has gone on the last push. So that is the one which will come out when you do pop. Okay, so you cannot remove element from below arbitrarily. You cannot remove 7 unless you remove 1. Only after removing 1 you can remove 7. Okay, so this kind of data structure is useful in many use case scenarios. For example, you want to reverse a string. So individual characters of the string, let us say name is the string and it contains some names, Ajay. So you have to go on extracting each character and push. A will get pushed, then J will get pushed, then A again and then Y. Okay, so this is how it get pushed, and when you call display, it will display Y, A, J, A. So it is easy to reverse a string using stack. Of course, there are more serious application cases like expression evaluation and expression conversion. So mathematical equations like a plus b star c, okay, so that can be done using stack. Now in this case, whether I should do a plus b first and or b star c first, that is decided by the operator precedence. Actually it is expected that b star c should happen first and then you should add a, right? But how do you tell computer to understand this logic? So that can be done using stack. So we shall see how stack can be used to do evaluate the expressions correctly if whenever a complicated expression is given, right? So let's see how I can implement stack using
Sir, one question there, stack.
yeah.
So it's only one element at a time we should be able to.
Yeah, we should be able to insert only one element at a time. That's right.
Okay.
Okay. Yeah. Now let's see the stack implementation. Class stack. We have elements. You can give any variable name here. I'm just calling it as elements and max size. So size of the stack is 10. Top is another variable. So in the constructor of this class, I would initialize top to -1. Sorry, top -1 like this. And I don't do anything else because array is already allocated a space. And then I need to define the methods push index. So here I'm going to check if top less than max size -1. It means there is enough space. Then I would say elements, I should increment the top first because it is -1 initially. It should become 0 because array index starts from 0 equal to the value that is coming from the push method, isn't it? And in the else part, suppose top has become equal to max -1, then I should point out that stack is full. You cannot insert the element. So this is in its simplest form how I can do a push operation.
Similarly, so 10th line, why it is -1, sir? Top -1?
Where?
10th line, constructor.
Here. See, how do you indicate stack is empty? If you make it 0, no, at 0th position there will be one element. Because this elements is an array. Array starts with index 0. Right.
To make it it's null, so where
null, if you make it null, then it will not be int data type, no? Okay, it has to be pointer. See, what this top is doing is it is counting how many elements are in the stack. When there are no elements, to indicate that condition I am using -1. That is more convenient. So that when I do plus top becomes 0, elements 0 at first location, the value gets stored.
Okay.
You visualize that stack horizontally. I showed it vertically. You show horizontally that 0th location you have X. Okay. And next time when you come again plus top means it will go to 1 and next element gets stored. So this is how the stack gets implemented, and you want to do pop where you want to remove the element from the stack. So here you have to check whether stack is empty. So suppose initially only you call top, then top would be -1. You say stack empty. Else it means if top is not -1, it is 0 or whatever, then you can say here, sorry, here you should say return elements top -. You should first remove the element and then decrement. Post decrement you must do, isn't it? So this is what will be done by pop. Now since it is expecting some return, here you are not returning anything, so you should return -1 if no element is found, stack is empty. So I should put this. Because this function is expecting something to be written, an integer value. If element is found, that gets returned, but if nothing is found, it is saying empty and then returning -1. So in the receiving function, you know exactly what is happening. Similarly, you can have a display, void display. So you can take from top to bottom, you have to display. So for int I is equal to top, I greater than equal to 0, I minus minus. I should do decrement here and say cout elements of I. And if you want to display them vertically, you can put an handle. So this is what I display. What remains is this peak value, that also can do in peak. So here again you check whether if top equal to -1, cout empty stack, and return -1. And the else part, you only have to return the top element. You don't have to decrement or anything. Just say elements of top. Okay, so these are the various methods that I have implemented. Now if I create a stack s1 dot push s1 dot push s1 dot push again. Now if I display, you see all elements getting displayed vertically. So 5 will come on the top. There should be a semicolon there. There should be a semicolon there. Hope there is a semicolon here also. Yeah. Still there is error. Yeah. So as you can stack full. Okay, so it should be else here. I have not given the else part. So that is why displaying stack full all the time. Okay, now you see on the top of the stack there is 5 and here it is 7 and this is 11. Is this implementation clear? How a stack can be implemented?
Yes, sir.
Okay, would you like to try this out?
Yeah.
Okay, just give a try. We shall see the pop operation and all later. Yeah, just implement this and see for yourself how the stack can be implemented.
Sir, can you call that peak?
Which one? Peak.
Right.
Okay.
Yeah.
You want to see what is the top element, right?
Yeah.
So you can just say cout s1 dot peak. Now 5 should be displayed, right?
Hmm.
After 11, 5 should come.
Okay.
Correct. Yeah. Now if you want to pop, you will get the again element 5 only. So cout, you can give pop the element is s1 dot pop.
And then can you do display again?
Yeah, we'll see after display 7 and 11 should come, right?
7, 11 should come.
Yeah. Okay, popped element is 5, so here and again you can say s1 dot display. Okay, popped element is 5 and
So
7
the
and 11.
size here you gave it as 10, right? So the stack is depending on whatever the size we are defining.
Yeah.
So it is not growing dynamically, right?
Yeah, it is not dynamic. That's why I told you. This is static implementation. So if you want dynamic implementation, you have to do exactly the way we did it for vector list.
Yeah, okay.
Where you have to have capacity here. That capacity will become double every time it hits the boundary.
Okay. For some use case, this is preferred, right?
This is where you have only 8 to 10 elements to deal with, you put that max size. But suppose you don't know how many elements will come, so that time you have to make it dynamic.
Okay. Okay, sir.
Yeah, just implement and see.
Yeah.
Now the same class can be modified to accept generic data type. All that you have to do is template angle bracket template t, and the changes that you have to make are t elements. Int top will not change because that is an index into the array. Push the value that you're pushing, that data type should be t. Pop, the return type should be t. Then display, there is no change, and in peak you should make it t. And now if I declare stack string s2 and push, let us say Akshay and maybe one more object, so I'm going to push one more, let us say maybe one more also, and display, you will see all three names displayed, and Faisal will come on top because that is the one which was pushed. It is getting displayed, but it is gone off the screen. That's the only thing. So Faisal, we know, then Akshay, as you can see, Faisal was the one which was pushed last, so that is coming on the top. So as you can see how easily you can modify implementation to a generic implementation just by making very few changes, and that is where you can appreciate why the template concept was very much supported in C++, and now you realize the importance of templates, how they are useful in simplifying the code and also reducing the effort required to implement same logic for different data objects. So you make few changes here and it would work perfectly same for data of any type. Alright, so we shall see more on this in our next lecture. Thank you so much.